Okay, so this video is going to be about end behavior. And when we talk about end behavior, we're looking at the ends of the graph and where they go in relation to the x and the y axis. So I always start off the same way. As x approaches infinity, what happens to my y? As x approaches negative infinity, what happens to my y? And y can be written as y and y can be written as f of x. So the way this reads, and what I have here is I have x and an arrow and the infinity symbol. And the way this reads is as x approaches infinity. And the question is, what happens to y? So as x gets larger, as my x gets larger and larger and larger, as it gets larger and larger and larger, what happens to y? Well, y is going down, so y approaches negative infinity. As x approaches negative infinity, as x gets smaller, what happens to y? Well, y is going up, so y is approaching positive infinity. And that's what end behavior is. End behavior is looking at the ends of the graph and asking what's happening. And the first part always stays the same. As x approaches infinity, what happens to the y? As x approaches negative infinity, what happens to y? So we're reading our graph. So we're kind of starting at the origin. We're saying, okay, as x gets bigger, does my graph go up or does it go down? As x gets smaller, does my graph go up or does it go down? If it goes up, then I'm going to infinity. If it goes down, then I'm going to a negative infinity. But it's read as x approaches infinity. And then it's read as y approaches infinity, or in this case, as f of x approaches negative infinity. So it's just telling me what happens. As I plug in bigger numbers for x, I get smaller numbers for y. As I plug in smaller numbers for x, I get bigger numbers for y. Let's look at another example. Okay, so let's look at this one. And again, they're going to start the same way. As x approaches infinity and as x approaches negative infinity. Those two parts are never going to change. The question is, what happens to y, or what happens to f of x? So f of x and f of x approaches what? And the only thing that I really have to plug in is this last part here, okay? So as f of x approaches, as x approaches infinity, positive infinity, does my graph go up or does it go down? Well, it goes up. So if it goes up, then that means it's approaching positive infinity. As my graph approaches negative infinity, does my graph go up or does it go down? It's going up, so f of x also approaches infinity. So in this case, this would read, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches infinity. Meaning on both sides of my graph, I'm going up on both ends. Okay, so this, again, we're going to start the same way. As x approaches infinity, as x approaches negative infinity. And I want to know the same thing. What happens to y? What happens to my f of x? So what does f of x approach? What does f of x approach? What happens to the y? So you can start with the negative. You can start with the positive. It doesn't really matter. So as x approaches infinity, so as x goes positive, what happens to my graph? My graph goes down. So x approaches negative infinity. As x gets negative, what happens to my graph? My graph goes down, so x also approaches negative infinity. Okay, still starting the same way. As x approaches infinity, your f of x, what is it going to approach? Let's see, as my x gets bigger, my y is getting bigger, so f of x also approaches infinity. As x approaches negative infinity, y is getting smaller, so y also approaches negative infinity. Now this one's a little bit different. So as x approaches infinity, if you notice, y is not going either just negative or positive. Y is actually approaching a number here. Y is getting closer and closer to the line y is equal to 1. So y, f of x, is approaching negative 1. As x approaches negative infinity, y is still approaching that line. That's a horizontal asymptote. So when I have a horizontal asymptote, my y's don't approach negative and positive infinity. They approach that asymptote. So it's still approaching negative 1. And that's okay. It's okay that it's approaching that asymptote. We just have to make note of that. So this is what happens when I have a horizontal asymptote. Now, if you want to rewind this a little bit, the picture before this didn't have a horizontal asymptote. It had a slant asymptote. So that graph actually looked more like this. And the bottom part looked like this. That's bad. But it had a horizontal asymptote in between the two. So it didn't have a vertical asymptote. It had a it didn't have a horizontal asymptote. It had a slant asymptote, which is different than my horizontal asymptote. So when I have a horizontal asymptote, I don't approach infinity, I approach that asymptote. Okay, we're going to look at some more with some horizontal asymptotes, but still every single one of these is going to start out the same. I'm still going to say as x approaches infinity, f of x approaches something, and that's what I'm going to fill in. As x approaches negative infinity, f of x approaches something, and that's what I'm going to fill in. So for every single one of these, that's what's going to happen. So that's going to be number 10. Number 11, as x approaches infinity, f of x approaches something. As x approaches negative infinity, f of x approaches something. And then for number 12, same thing. As x approaches infinity, f of x approaches something. As x approaches negative infinity, f of x approaches something. So let's look at number 10. In number 10, it appears that my horizontal asymptote is actually my x-axis. Well, my x-axis is y is equal to 0. So as x approaches infinity, f of x approaches 0. As x approaches negative infinity, f of x approaches 0. For number 11, I have a horizontal asymptote right here, and so that's at negative 1, 2, 3. So as x approaches infinity, f of x approaches that horizontal asymptote at y is equal to negative 3. Same with negative infinity. As x approaches negative infinity, my y still approaches that horizontal asymptote. For number 12, I have a horizontal asymptote here, and that's at y is equal to 2. So my horizontal asymptote is where we're approaching. So as x approaches infinity, y approaches 2. As x approaches negative infinity, y still approaches 2. Okay, so these are still about end behavior, so I'm still starting the exact same way. As x approaches infinity, what happens with my f of x? As x approaches negative infinity, what happens to my f of x? Same thing for 14 and 15. Okay, so what's going to throw you off with number 13 is the fact that I have parts of my graph up here. But remember, I'm looking at the end behavior. So what's happening at the end of my graph? So if I look at the end, when x approaches infinity, I'm getting closer and closer again to this horizontal asymptote. And my horizontal asymptote is at negative 2. Even though this part of my graph is up at the top, is ending up at the top, that's not my end behavior. That's actually in the middle of my graph. So I'm not focusing on that. I'm focusing again on the ends. As x approaches negative infinity, y is still getting closer and closer to that asymptote, which is negative 2. On number 14, I'm looking at, again, I'm not looking at the middle of the graph, I'm looking at the end. So as x is approaching infinity, I'm getting closer and closer to my x-axis, which is y is equal to 0. as x approaches negative infinity, same thing, I'm getting closer and closer to my y-axis, or to my x-axis, which is y is equal to 0. So, and last but not least, as x approaches infinity, I'm getting closer and closer to this isotope here, which appears to be -5. However, as x approaches negative infinity, I am going off my graph. It's not the middle of it, so y is actually approaching positive infinity. So it's possible for my end behaviors, for my y's to be going to positive infinity or negative infinity, and it's also possible for them to be approaching my horizontal isotopes. And you just kind of need to pay attention to what's happening on the ends of the graph, not in the middle of the graph, because if we focus on the middle of the graph, then we will get that part wrong, okay?